Hey TechKnowStuds! In this lesson, we're going to go over solid-state drives and some of the differences between solid-state drives and these old magnetic drives. First thing to realize that one of the best upgrades you could make to your computer a while ago was to move to a solid-state drive. That is, these hard disk drives were just so slow. And then once you did that upgrade to these solid-state drives, it really improved the performance of the machine. That's because there's no physical moving parts inside a solid-state drive, where there is in this hard disk drive where it has to actually search for the data. So this is a great upgrade, and now most computers nowadays have some element of solid-state drives. So for instance, my computer that I'm doing my editing on and that I have right here that I do a lot of my work on is all on these, most of my data is on these solid-state drives, and then I have a hard disk drive, a really big hard disk drive that does all of my backing up. So once I'm done editing things, I put it on one of these hard disk drives for long-term backup because I can buy lots of storage for pretty cheap. Now, when it comes to form factors and interfaces, solid-state drives have some of the most variety to it. And that's because we had all of these hard disk drives before, and they had certain sizes and shapes. So when solid-state drive came along and started replacing our hard disk drives, they needed to match the same size and shape. However, as they became more prevalent, what we started doing is we started making them smaller, and we started making them faster. And so we started creating different form factors when it comes to solid-state drives and different interfaces and different protocols for communicating. And so we have some of the most variety now with the solid-state drives. This is an example of a 2.5-inch form factor that uses SATA as the connection. This is an example of an mSATA form factor that uses SATA as the connection. And this is an example of an M.2 that uses PCIe as the connection and NVMe as the communication. If you want to take a look at inside of what you would see inside of a solid-state drive, we can see that there's different chips here, just like we see here on this board and this board, although they're covered up by some stickers there. But essentially, yes, it's all these chips that are storing the data. That's where the data gets stored. The purpose of solid-state drives is really to have non-volatile storage. However, there are a few edge cases where that uses volatile, but with a battery backup to make it non-volatile. So that's primarily the characteristic that we're looking at. And of course, it's using solid-state technology. And we use this in a lot of different components on the computer. And then we also have many different form factors that we can find it out there. And then also many different protocols that we use with solid state.